We are Helmets Are Us, and we want NASA to produce our helmet.
Health research funding reported that more than 250,000 children visit emergency rooms every year due to concussions or other traumatic, horrid brain injuries every year due to sports-related injuries. Football players have a 75% chance of suffering a concussion in one season. Furthermore, Edwin Rios stated that between 2005 and 2014, 92 high school players died of concussions-related injuries.
That is why we want NASA to produce our helmet.
SNN Newsroom.
Football is one of America's favorite sports. It is a fast, physical game. Professor Samuel from Wagner Edge Elementary has come up with a helmet that may stop head injuries in our beloved sport.
Football helmets have been around for a long time. They've been from leather head coverings to helmets that are protective but focus more on comfort and weight that are made for brands such as Riddle and Rawlings. Recently, NFL released a preview of its newest helmet, which is said to have motion sensors built into it to sense a player coming in for a tackle.
What are the limits to this helmet?
Some limits for the helmet would be the weight of the helmet. It cannot be too heavy. Secondly, the temperature inside the helmet. We will not want it to be too hot, otherwise the athlete could get heat exhaustion. Thirdly, the cost of the helmet based on the materials we want to use. And lastly, for our real test, we might have to use real people and we will not want to cause head injuries.
What are some solutions to this problem?
We thought of several solutions while making our helmet. First of all, we want to use lightweight and strong materials. We thought of Kevlar and carbon fiber, which are both movable. Second of all, we wanted to put in a cooling system in the helmet. We thought of putting in either air vents or gel foam. Also, we wanted to put an impact sensor for the helmet to tell the severity of the hit on the player. Red means that the player needs to be taken out. Yellow is a caution, and green is that they can continue to play. Lastly, we wanted to think of putting an oobleck, which is a non-Newtonian fluid, which means its physical state is a liquid, but on impact it's a solid. We thought of putting in the first three because oobleck isn't a good idea because it could change its state of matter in the helmet, which would be very uncomfortable to the athlete. Lastly, for the cooling system, we decided to put in the gel foam because the air vents could crack or get hurt in the helmet.
Professor, will you please show us the model of this helmet?
We could not get the actual material, so we improvised. The foil simulates the carbon fiber and Kevlar outer shell. The inside, or the diaper material, simulates the gel foam. And lastly, right here, the orange peel simulates the motion sensor.
How did your drawing help your model, and how will it help others?
Our drawing helped us because it made our building easier because we already knew where to put the materials. It will help others because if it turns out our helmet will be made by a company, they will know what our helmet is supposed to look like.
Professor, are there any differences between the drawing and the model?
In our first drawing, we used different and more heavier materials such as a cold water pack and the oobleck. But in our second drawing, we improvised and made sure that we got rid of the oobleck. Instead of the cold water pack, we used gel foam, and then we weaved the carbon fiber and Kevlar together, which made a very strong shell, and it was lightweight as well.
What are some strengths and weaknesses of this product?
Some weaknesses of the helmet could include that the battery pack and the gel foam could weigh the player down. Also, once in a while, the battery pack could lose power. Some of the strengths of the helmet could include that the very strong carbon fiber and Kevlar fusion shell, which in some cases is nearly impenetrable. The gel foam is working both ways, both as a coolant and as a cushioner in case of impact.